Greetings viewers, welcome to Righteous Academy. I welcome you to this tutorial video where I'll be teaching chemistry on this topic known as the kinetic theory of matter. So before we begin with this topic, one has to know the meaning of these two words, which are physical change and chemical change. So when they say physical change, they mean to say change in appearance. Change in appearance, the change in state. So physical change, a good example I can give, it is on the heating curve, we have a solid changing into a liquid, then changing into a gas. That is a good example of physical change. Then second, we have chemical change. Chemical change, this is the formation of a new substance, meaning a chemical reaction has taken place. So, questions may come in the exam room where they tell you to differentiate between physical change and chemical change. So, physical change does not involve the formation of a new substance, while chemical change involves the formation of a new substance. Then second, one can also say physical change does not involve the absorption or release of energy, while chemical change involves the absorption or release of energy. So now, after understanding these two words, we can now move on to discuss more on the kinetic theory of matter. So first of all, here we have this word which is kinetic. Kinetic, we all know it means motion. In terms of energy, when they say kinetic energy, they mean to say energy in motion. So here this word, it is meaning motion. Then here we have matter, theory of matter. So the theory of matter states that matter is made up of tiny particles. Now, when they say kinetic theory of matter, they are trying to tell you that the motion in which those tiny particles of matter are found, the motion in which those tiny particles of matter exist, the continuous motion of those tiny particles which make up matter. So the kinetic theory of matter states that matter is made up of tiny particles, and these tiny particles are in continuous motion. Continuous motion, which is the meaning of kinetic energy. When the theory of matter, it is matter is made up of tiny particles. So in the exam room, when they tell you to say what is the meaning of the kinetic theory of matter, or what is the kinetic theory of matter, or state the kinetic theory of matter. The kinetic theory of matter simply states that matter is made up of tiny particles, and those particles are in continuous motion. So now, for those particles to be in continuous motion, there has to be processes that are taking place to lead to those particles to be in motion, or to be responsible for the movement that is taking place between those particles. So here we have three processes of which we have to understand. So number one, we have diffusion. Then second, we have osmosis. Then lastly, we have active transport. Active transport. So let me first start with diffusion. So diffusion, it is the process that involves the movement of particles from a region of higher concentration to a region of lower concentration. So diffusion, it is the movement of particles. Diffusion, it is the movement of particles from a region of higher concentration to a region of lower concentration. Now, then osmosis, here osmosis, it only means the diffusion of water molecules. When we say the diffusion of water molecules, we are only trying to say the movement of water molecules from a region of higher concentration to a region of lower concentration. So it is the same way as saying osmosis. It is the movement of water molecules from a region of higher concentration to a region of lower concentration through a permeable membrane or through a membrane. Then lastly, we have active transport. So active transport, it is the movement now in the opposite direction. So the movement from a lower concentration to a higher concentration. So the movement of particles or molecules. So active transport, it is the movement of particles or molecules. The movement of particles or molecules from a region of lower concentration to a region of higher concentration using energy in form of ATP. Using energy in form of ATP. Using energy in form of ATP. Now, after understanding these three processes which are responsible for the continuous movement of those tiny particles in which matter or which make up matter, we have to understand that there are factors that may lead to diffusion taking place. There are factors that may lead to osmosis taking place. There are factors that may lead to active transport taking place. So these factors, number one, we have temperature. So increase in temperature increases the rate at which diffusion takes place. Increase in temperature also increases the rate at which osmosis takes place. Then we also have concentration. Concentration increases the rate at which diffusion is going to take place. Concentration also increases the rate at which osmosis is going to take place. Then third, we have size of particles. The size of particle also affects the rate at which diffusion is going to take place and the rate at which osmosis is going to take place. So the size of particle, this is just the size of those tiny particles. So when we have the smallest size, diffusion is going to take place at a higher rate. But when we have large particles, diffusion is going to take place at a lower rate. Now, after understanding those factors, now we have to provide the evidence that was given to make sure that we know that truly matter is in continuous motion. So there is this evidence that was given to prove that truly matter is in continuous motion. And this evidence, it is known as Brownian motion. So questions may come, give the evidence that proves the kinetic field of matter. So the answer is Brownian motion. So we have to discuss more about Brownian motion. Brownian motion. Brownian motion. So Brownian motion, this is the random movement of particles in a substance. So Brownian motion, it is the random movement of particles in a substance. The movement, the motion of particles in a substance. That is what we call Brownian motion. Then after now knowing Brownian motion, we are just going to move on now to the apparatus or the devices that are found in the laboratory. So in the laboratory, we have found many different apparatuses of which one has to know. So in chemistry, we have these apparatus that are very confusing to learners. So it is very easy for you to know the meaning of a test tube, because a test tube, it is used when mixing different chemicals. Then you can also know the meaning of a beam balance, measuring mass, the function of the spring balance, which is measured in weight. Then we also have these two apparatuses which many of us make a lot of mistake. Number one, we have the burette, and here we are going to have the measuring cylinder. Measuring cylinder. So the burette, it is used to measure volume. Then also the measuring cylinder, it is used to measure volume. Now, what differentiates these two is the burette, it is used to measure accurate volume, while the measuring cylinder, it is used to measure approximate volume. So the burette measures accurate volume, while the measuring cylinder, it measures the approximate volume. So after understanding this, we have to now to move on to the terms used in chemistry. The terms used in chemistry. In chemistry or laboratory. So number one we have mixture. Then second we have solution. Third we have solvent. Then solute. And we also have immiscible. Then there is also miscible. So these are the new terms we are going to find in chemistry. Number one, we have a mixture. So a mixture, a combination of two or more elements. Then the solution, it is a substance made up of a solute and a solvent. A substance made up of a solute and a solvent. A solvent, when third we have a solvent. A solvent, it is a substance in which a solute dissolves. A solvent is a substance in which a solute dissolves. So a good example of a solvent, we have ethanol and water. Then solute, it is a substance that dissolves in a solvent. So a solute is that substance which is going to be placed in water, or that substance which is going to be put in ethanol for it to dissolve. Then we also have these two last terms which are immiscible. So immiscible meaning the solution, it is not mixing uniformly. So the solution that is not mixing uniformly. The solution that is not mixing uniformly. The solution which is showing different layers. The solution that is showing different layers. Then when we say miscible liquids, a solution that mix uniformly. A solution that mix uniformly. A solution that does not show different layers. So now after understanding this, we move on now to the last part, of which is the separation techniques. So I've seen so many people facing challenges on this one. Separation technique. Separation technique. Separation techniques. Number one, we have filtration. Filtration, what we have to understand on filtration is the definition for filtration. So filtration, the process of separating a pure liquid from a solution containing solid particles. The process of separating a pure liquid from a solution containing solid particles. No wonder we use the filter paper so that the solid particles may be trapped. So the diagram, it is very simple. You just have a tripod stand, and you also have a funnel here, and here you have a beaker to collect the liquid which is going to be passing through the funnel. Here we have the filter paper. So here where we have the filter paper, we know that here it is where we are going to find those solid particles, of which we are supposed to call as residue. Then the liquid which is going to be collected, it is going to be called filtrate. Then here we have our tripod stand. Then we move on to distillation. We also have this process known as distillation. So distillation, it is the process of vaporizing a liquid. Vaporizing a liquid and condensing the vapor. The process of vaporizing a liquid and condensing the vapor. So we have two types of distillation. Number one, we have simple distillation. Then we also have fractional distillation. Fractional distillation. Fractional distillation. So simple distillation is a process of obtaining a pure liquid from an impure solution, meaning a solution is containing some impurities. So for us to collect a pure liquid, we have to carry out simple distillation so that the impurities may be left out, and as we condense the vapor, eventually we are going to collect a pure liquid. So simple distillation, the process of obtaining a pure liquid from an impure solution. So simple distillation, the diagram is very simple. You just have here the round bottom flask. Then here we have a light big condenser. Then here you have a beaker. Then here we have a tripod stand. You have a source of light, source of heat. So as the liquid vaporizes, the vapor is going to come in the light big condenser. So this is just an illustration for simple distillation. We are not trying to draw something which is going to look good, but I'm just trying to make you understand more. So when this liquid reaches its boiling point, it is going to turn into vapor. As it turns into vapor, the vapor comes into the light big condenser. Now, in the light big condenser, condensation takes place. The gas turns into a liquid. So a liquid is going to be collected in the beaker. So that liquid that is going to be collected, it is called the distillate. The distillate, it is the pure liquid. Then here we have a light big condenser. Light big condenser where condensation takes place. So this is just an illustration of simple distillation. Then we also have fractional distillation. So fractional distillation, again we have a round bottom flask. Then here we have a source of heat. Here we have a source of heat. Then here inside we have glass beads. Then on top we are going to have a light big condenser. This side. Then at the top we're going to have a thermometer at the top. So this is just an illustration. So on top we are going to have a thermometer. Then inside here we have glass beads. So this is a light big condenser delivering the liquid into the beaker. So when this solution is heated, the vapor passes through these small spaces left by the glass beads. So the function of the glass beads, it is to increase the surface area at which condensation takes place. So to increase the surface area at which condensation is taking place. Then here we have the thermometer. The thermometer, it is to measure the temperature. So here, what is making a difference between simple distillation and fractional distillation? It is the liquid being used. So here the liquid that is being used, it is called miscible liquid because it contains two different types of liquids that mix uniformly. A good example of which we usually give in chemistry is water and alcohol. Water and alcohol. So alcohol of which we usually use is ethanol. So when you mix water and ethanol, you are going to form a miscible liquid that can be that can be separated using fractional distillation. So this miscible liquid can be collected based on two conditions. Sometimes those conditions are termed as a criterion. So sometimes those conditions are termed as a criterion. So these two conditions, number one, they have to be miscible liquid. They have to be miscible liquid. The solution being separated, it has to be a miscible solution. It has to be a miscible solution. Then second, we have to have different boiling point. Different boiling points. So these are the two conditions that guides a liquid that is supposed to be separated using fractional distillation. So simple distillation, here we just have a liquid which is an impure liquid. Then here we have a miscible liquid. So apart from this, we also have magnetism. Magnetism can be used to separate magnetic materials from non-magnetic materials. Then we also have decantation. So third, we also have magnetism. And fourth, we also have decantation. Then we also have crystallization. The process of forming crystals. Then lastly, we are supposed to talk about chromatography. So lastly, we are supposed to talk about chromatography. So chromatography, this is just the process of separating the contents of a substance. The contents of a substance. So for example, you may have glucose solution. So we're going to use this one as a good example for chromatograph glucose solution. In glucose solution, we know that here we have water and glucose. Water and glucose. So here we have water and glucose. So we are going to have a diagram. It's going to look like this. So this is the chromatograph paper. So this is the line. So here we have our glucose solution. So our glucose solution, we're going to label it GS, glucose solution. It is going to make, it is going to leave a dot here, and also dot here. Then here we are going to have H2O, and here we are going to have glucose only. So glucose only, we are going to find it is going to have a dot that is going to be in the same line as one of the three dots of which we have in glucose solution, because glucose solution contains glucose. So being in the same line, it means it is one of the same, it is one of the same thing, or this one, it is found in this solution. So glucose, it is or glucose is present in this glucose solution. Then on H2O, you are going to find that again you are going to have a dot that is going to be in the same line as one of the dots of glucose solution. Then here when you say you have maybe, let me say maybe color red, you are going to find that this one, it is going to have dots where we have no content of, or where we have no dot which is going to appear coming from glucose solution. So which means this color red, it is not found in glucose solution, but the glucose and the H2O, they are found in glucose solution. So here again, what we need to understand, it is the retardation factor. So retardation factor, questions may come, retardation factor. So retardation factor, distance is equals to distance moved by the solute. Distance moved by the solute over distance of the solvent. Distance moved by the solute over distance moved by the solvent. So the solvent, it is from the top to down here. So a good example, maybe here we have 2 meters. Then here we are going to have this distance from the distance between the glucose content, this one. We are going to take this distance as 0.5. So here we are going to say 0.5 over 2. So 0.5 over 2, this is science, you can take your calculator, but since I want to solve it mathematically, I can also do here times 10, here times 10, on top we are going to have 5, at the bottom 20, 5 here, 1, 5 here, 4. 1 over 4, it is the same as 0.25. So this is going to be your retardation factor. So after now understanding how to find the retardation factor, you have to also understand the application of these processes. So these processes, of which are taught on separation techniques. Number 1, filtration can be carried out at waterworks. Then distillation can be carried out to prevent diseases. Then we also have magnetism, which can be carried out to prevent mixing of non-magnetic materials with magnetic materials. Then we also have crystallization, which can be carried out by industries, which are responsible for manufacturing sugar and salt. Then chromatography, it can be carried out by food industries to prevent impurities, to prevent the presence of impurities found in food, because chromatography it is able to show the contents in a substance. So this was all I had prepared for you. So before you leave this video, I want you to subscribe, like the video, and share this video 100 times. Comment. We need your ideas, your suggestions. We need people. So let's grow this channel together. So this has been Righteous Academy. Thank you.
This is Righteous Academy, where we explain in simpler terms. Righteous Academy, got you covered, no worries, we are here.